Okay, in lesson 9, we're going to talk about quads and polygons. All right, so you're going to spend a lot of time in geometry talking about quadrilaterals themselves. Like we spend a lot of time talking about triangles. All right, but you're also, before you start talking about quadrilaterals, you're going to introduce polygons. So a polygon is a closed figure formed by three or more line segments called sides. The sum of the measures of the interior angles in any polygon can be determined by the number of triangles. Remember the inside angle theorem of a triangle says that all three angles add up to 180, and you can cut any polygon that's bigger than a triangle into a number of triangles. And so how many 180s are we talking about? And so this is what this chart is going to help us with. So for a triangle, you have three sides. For a quad, you have 4. Pentagon, you have 5. Hexagon, you have 6. Heptagon, you have 7. Octagon, you have 8. Nonagon, you have 9. And decagon, you have 10. And you can go higher, but this is enough to show the pattern of what we're trying to get at. All right, so you have a number of triangles. You have one triangle, you have two triangles, 3, 4, 5, 6, 7, and 8 triangles. Okay, so if you take a square or a rectangle and draw from one corner to the other, you get 2 triangles. If you take a pentagon, you can take one vertex and draw 3 triangles. And so how many triangles do you have? That means how many 180s do you have? So if you have one triangle, you have 180 degrees. If you have 2, that's 360. If you have 3, that's 540. 4 would be 720. 5 would be 900. 6 would be 1080. All right, 7 would be 1260. And then 8 would be 1440. And I've already done those calculations, so I'm not asking you to do those. That's why I was able to do it so fast. But from this chart, we can see that there's a pattern going on, and any pattern can be written with a formula. So if n represents the number of sides of a polygon, then the sum of the interior angle S can be found with the formula S equals 180 times n minus 2, where n is the number of sides. Okay, and then a regular polygon is a polygon which all side measures are congruent. Therefore, all angles are congruent. Okay, and then the sum of the exterior angle is always 360. Okay, so let's see, we have 1, 2, 3, 4, 5, 6 sides. If we have 6 angles, we have 6 sides. So I'm going to add all these up. This is going to be 110 plus 8x minus 1 plus 5x plus 36 plus 116 plus 7x plus 19 plus 6x minus 2. And how many, what's the degree for 6 sides? So the hexagon would be 720. So I set this equal to 720. Now, if this was a regular hexagon, then all sides and all angles would be congruent, and this would be an easier problem. But because this is not a regular polygon, I have to set it up this way. And so you add all those up, and you get 26x plus 278 equals 720. So 26x equals 442. X equals 17. Okay. For number 2, it's a quad. So we know this is going to add up to 360. So you add all this up. 10x plus 13 plus 14x minus 11 plus 8x plus 7 plus 5x plus 18 equals 360. Does it matter which order you go in your angles? Not at all. As long as they're all present, you can't do it wrong. Okay, you add all that up, you get 37x plus 27 equals 360. 37x equals 333. Divide, you get x equals 9. All right. Now, on 3, we have a regular pentagon, which means all sides and angles are equal. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so we have 10 sides. We know that that's going to be 1440. But 1440 divided by 10 is 144, which means this individual angle, 10x plus 4 equals 144. Now, you could also set this up this way. So 10 times 10x plus 4 equals 1440. And then divide by 10 that way to get started. Either way, because you got 10x equals 140, x equals 14. All right, so not too bad. And again, if you're dealing with exterior angles, they all add up to 360. So I'm going to take all of these numbers and set them equal to 360. All right, so you got 5x plus 4 plus 4x plus 9 plus 9x minus 6 plus 4x plus 1 plus 7x plus 4 equals 360. You combine like terms, you get 29x plus 12 equals 360. So 29x equals 348. Divide by 29, you get x equals 12. Now, depending on the age of your students and the level of your students, you may want to include problems that come out to not be a whole number, just to show that that's an option. Because if you work problems that come out evenly all the time, students start to get a feel for anything other than that is wrong. So it's encouraging to give them some answers that are not exact answers all the time. Okay, so when you get into actual quadrilaterals and specifically, and not just polygons, you start looking at parallelograms, rectangles, rhombus, square, trapezoid, isosceles trapezoids, and kites. And each one of those has a set of properties. And so you slowly build this chart over time. But the properties you're dealing with, some of the sides opposite sides are parallel, opposite sides congruent, opposite angles are congruent, diagonals bisect each other, diagonals are congruent, diagonals are perpendicular, 4 right angles, 4 congruent sides. And so depending on whether you're talking about a parallelogram, rectangle, rhombus, square, trapezoid, kite, or whatever, you're dealing with a different set of properties. And this chart lays them all out. And so we'll refer to this a couple times as we work the following problems. On number 5, this is a parallelogram. And in a parallelogram, opposite sides are congruent. So I'm going to set these two equal to each other. So 9x minus 25 equals 5x plus 7. This is going to be 4x minus 25 equals 7. 4x equals 32. X equals 8. Okay. All right, for 6, we're again dealing with a parallelogram. And in a parallelogram, opposite angles are congruent. So angle A is equal to angle C. And so I set these equal to each other. 6x minus 15 equals 4x plus 11. So it's going to be 2x minus 15 equals 11. 2x equals 26. X equals 13. Now, I found x, but they asked me to go find angle B. Okay, so if I plug this in, I know that 4 times 13 plus 11, 4 times 13 is 52, that's going to be 63. So if this is 63, then adjacent angles in a parallelogram are supplementary. Okay, so 180 minus 63 gives me 117. Yeah, 117. All right, so angle B is 117. So as your students get more accustomed to the problems, it's a good idea not just to solve for x, but to take it a step further like we did here on number 6. All right, on 7, still dealing with parallelograms, but all right, so this angle and this angle are the same. This angle and this angle are the same. All right, if ABC, this entire angle up here, is 115, that means these two angles, the 4x plus 6 and the 6x minus 11, together are going to add to 115. So 4x plus 6 plus 6x minus 11 equals 115. Okay, so it's going to be 10x minus 5 equals 115. Add 5, you get 10x equals 120. X equals 12. Okay, so you got x, but you got to go find ADB. So ADB is this angle right here. ADB, this angle right here. Okay, so I just plug 12 into that one, and so 6 times 12 minus 11. All right, that's 72 minus 11, so that's going to be 61. 61 degrees. All right, number 8. All right, we have a rectangle. And a rectangle, all right, so let's look at the properties of the rectangle. Rectangle, opposite sides are parallel. Opposite sides are congruent. Opposite angles are congruent. Diagonals bisect each other. The diagonals are congruent. And you have 4 right angles. Okay, well, because these are right angles in the corner, I know that these 2 angles are going to add up to 90. No, these 2 are right angles, but because these 2 sides are parallel, I know that this angle and this angle are congruent because of alternate interior. Okay, so I set them equal to each other. 11x minus 3 equals 7x plus 5. All right, so you get 4x minus 3 equals 5. 4x equals 8. X equals 2. It says go find BCE. BCE is this angle right here. All right, so now the 90 comes in, and you say, you go find one of these angles. All right, so this is going to be, let's see, 11 times 2 minus 3. This is going to be 22 minus 3, which is 19. So if this is 19, 90 minus 19 would be 71. So the measure of BCE is 71 degrees. Okay. On 9, you're dealing with a rectangle, and you have a couple things that, first of all, because the diagonals are congruent, I know these 2 sides are congruent. All right, and I know that these 2 angles right here add up to 180. So 134 from 180 is going to be 46. So if this is 46, that means that my base angles are congruent. So this is congruent to this, and so add 134 divided by 2 is 77. So this angle is 77, this angle is 77. So if you knew the exterior angle theorem, you could avoid the 46 and just go straight to, hey, I know those 2 angles are congruent. So 134 divided by 2, or sorry, those 2 angles are congruent. They also add up to 134. So 134 divided by 2, you get 77, which makes this 5x plus 7 equals 77. 5x equals 70, x equals 14. So sometimes I like to find the angles inside first, so it makes my job a little easier. So by finding that angle is actually 77 degrees, it makes the algebra a little easier. Okay, so if this is a rhombus, find MP. So I want to find this angle right here. Well, the thing with a rhombus is all sides are congruent. So parallel sides are congruent, opposite sides are congruent, opposite angles are congruent, diagonals bisect each other, diagonals are perpendicular, and you have 4 congruent sides. All right, so because the sides are congruent, I'm going to set them equal to each other. 9x minus 77 equals 3x plus 7. This is going to give me x. So you get 6x minus 77 equals equals 7. 6x equals 84. X equals 14. All right, and then you just need to plug it into one of them. So 3 times 14 plus 7. That's going to give you 42 plus 7. That's going to be 49. And if one side is 49, all sides are 49. So that's my answer, because it's a rhombus. Number 11, you're dealing with a square. So SW is 2x plus 13. WU is 8x minus 41. These 2 are congruent. These 2 are congruent. and they're congruent to each other because it's a square. Finding VT, I need to set these two equal to each other, and then plug it back in. So you got 8x minus 41 equals 2x plus 13. All right, so this is going to give you 6x minus 41 equals 13. 6x equals 54. X equals 9. So I plug this back into one of them. So let's say 2 times 9 plus 13. This is going to give you 18 plus 13 is 31. All right, so if this is 31, all of them are 31. Okay, so finding VT is simple. You just say 31 times 2. So VT equals 2 times 31, which is 62. Okay, for number 12, we're dealing with a trapezoid, and opposite sides are parallel, as you can see from the arrows. And so that means these two angles are 180, so you can add them up, set them equal to 180, or 180 minus 54 is going to be 126. So that means that angle right there is 26, or 126, so 8x plus 6 equals 126. 8x equals 120. X equals 15. So whether you add the 54 and set it equal to 180, or you find the individual angle and set it equal to that, it's just two different ways of working it. And your students are going to pick, you're going to have a mix of both as your students work it. All right, 13, you have an isosceles triangle, a trapezoid. Okay, so when it's isosceles, that means these two sides right here are congruent, which means if these two sides are supplementary, if these two angles are supplementary and these two angles are congruent, that means opposite angles are congruent. Or not congruent, but opposite angles are supplementary. So 14x minus 25 plus 3x plus 1 equals 180. This is going to give you 17x minus 24 equals 180. 17x equals 204. X equals 12. Okay. All right, for kites. So 14 and 15 deal with kites. So let's go back and look at our chart. Our kite, opposite angles are congruent. You only have one pair of them. And I'll show you exactly which ones in a minute, and then diagonals are perpendicular. So when you're dealing with kite, opposite angles are congruent. That's these two right here. The two, you have two congruent short sides and two congruent long sides. And the angle in between the short and the long, those are congruent to each other. So you have congruent angles here, and then opposite diagonals are perpendicular. All right, so for 14, it's a quad. So I know all angles add up to 180. So if that's, both of these are 109. So let's see. You can add them all up. 5x plus 14 plus 3x plus 8 plus 109 plus 109. You could also say 218, which is the same thing, equals 360. You combine like terms, and you get 8x, let's see, 218 plus 8 plus 14 is 240. So 8x equals 120. X equals 15. Okay. For 15, because triangles, or the diagonals are perpendicular to one another, that's a right angle, which means these two angles add up to 90. So you got 9x plus 1 plus 23x minus 7 equals 90. So it's going to be 32x minus 6 equals 90. 32x equals 96. X equals 3. All right, and then it says go find STV. STV is this angle right here, Well, that's the same as this angle right here. So 9 times 3 plus 1. It's going to be 28. Okay, so that's your angle. Now, it is helpful and a little more advanced if you prove using a coordinate plane, using points in a coordinate plane, whether you have a parallelogram, rectangle, rhombus, or square, like proving some of these figures to be true. So for 16 and 17, we're going to find the distance formula. So I'm looking for AB. I think all four sides. So AB, BC, CD, and AD. And that's going to tell me about my sides. So I have 8 minus 9 squared plus -2 minus -4 squared. And using my calculator, I find that to be square root of 5. On BC, I have 2 minus 8 squared plus -5 minus -2 squared. And if I use my calculator, I get square root of 45. All right, CD, I have 3 minus 2 squared plus -7 minus -5 squared. It's going to give me square root of 5. And then AD is going to give me 3 minus 9 squared plus -7 minus -4 squared. Using my calculator, I get square root of 45. So this is telling me that opposite sides are congruent. So using my chart, opposite sides are congruent, opposite sides are congruent. All right, so this is either going to be a parallelogram or a rectangle. So parallelogram or rectangle. And so the second part of that is, are the diagonals congruent or are they not congruent? And so I would need to then find AC and BD. So AC is going to be 2 minus 9 squared plus -5 minus -4 squared. And that tells me that gives me square root of 50. And then BD, I get 3 minus 8 squared plus -7 minus -2 squared. And the calculator says that's square root of 50. So since my diagonals are congruent, that means this is not a parallelogram, but a rectangle. Okay. One more. So we're looking for sides first. So I got QR, RS, ST, and QT. All right, so the first one, that's going to give me, let's see, I got 1 minus -2 squared plus -5 minus -7 squared. The calculator says that's going to be square root of 13. RS, that's going to be 4 minus 1 squared plus -7 minus -5 squared. Calculator says that's also square root of 13. All right, ST, that's going to be 1 minus 4 squared plus -9 minus -7 squared. Calculator says that's square root of 13. All right, QT, that's going to be 1 minus -2 squared plus -9 minus -7 squared. And that's also square root of 13. So since all sides are congruent, this is either going to be a rhombus or a square. So I need to look at diagonals now. So I'm going to look at QS and I'm going to look at RT. All right, so QS, that would be 4 minus -2 squared plus -7 minus -7 squared. All right, and that's going to give me 6. Okay, and then RT, that's going to be 1 minus 1 squared plus -9 minus -5 squared. And that's going to result in 4. Okay, so that's going to give me opposite, or I got diagonals that are not congruent. If they were congruent, it would be a square, but since they're not, this is a rhombus. Okay, so once again, taking these ideas and going to the coordinate system and proving these things using the distance formula is an advanced skill. And depending on where your students are, if you got an advanced math class or something like that, maybe you throw this in here. Okay? All right, so that's lesson 9. I'll see you in the next lesson.